right, let's go ahead and finish the lesson. So now we are in example 6. That is page 483. I'm going to read these and you can look at the picture. I recommend you drawing the picture out. It kind of makes you see the triangle a lot more and see what you need to find. Example 6. So from a point on the ground, 500 feet from the base of the building, so that's that bottom portion right here, an observer finds that the angle of elevation, so that means increasing, so that means from here going on up, elevation to the top of the building, so just to the top of the building is 24 degrees. And the angle of elevation to the top of the flagpole, so now we're comparing two different triangles, so from the building and to the flagpole, and they said the flagpole up here is 27 degrees. Here it says find the height of the building and the length of the flagpole. So we need to find the height of this and the height of the cave right there. And then the flagpole, we're just going to have to find actually this small portion right here. Well, we can simply find that by doing something in the very end. Well, let's go ahead and find the H and the K first. So we're going to find the two main triangles here. So from the building here, I have it's 24 degrees. The height is H. And here, the base from the angle to the building is 500. So here, I have to see what property I need to use. So from the angle, 500 is considered adjacent. Height is considered opposite. So that means I'm going to be using tangent. So tangent is opposite over adjacent. So now I'm going to go ahead and find it. So tangent of 24 is equal to opposite, which is H, over adjacent, which is 500. Now you solve for H. Multiply both sides by 500. And then you have H as being, I have it about, and I round it to the nearest whole number. It's about 223 feet. So that's the height of the building. Now let's look at the flagpole. Let's look at the main triangle itself though before we start finding the length of the flagpole. We have to find the small portion, but we need this big portion to solve out for that small portion. So let's say we're going to take this whole big triangle here. The angle is 27 degrees. The base here is still the same as 500, and the K is our new height, what we're trying to look for. Here, now we have to compare it to see what kind of trig function we're going to use. Adjacent, ADJ, opposite, that's considered tangent. Tangent is equal to opposite over adjacent. So now it's a tangent of a new angle, which is 27, is equal to the opposite side, which is K, over the adjacent side. Notice they're going to be two different answers because it's 24 degrees, 27 degrees. They're going to give you a different answer. So now 500, you're going to get the K by itself, multiply 500 on both sides, and you end up with K being, so rounding to the nearest whole number, 255. And the last part is we're trying to find the length of this section right here. So what we do to find this, the length of that small section there, we're going to do what K is, and we're going to subtract it from our H. K is 255. Yeah, 255. Minus 223. You get 2, 3, and that would be about an average of 32 feet there. So we have to use our triangles to compare the two, but we can't just do 223 plus something. We don't know what the whole length of the whole thing, including the flagpole, is. So just do some math, try to work your way around, see what they're actually asking you. They're not trying to ask you to find the length of the whole thing. Now, line of sight, I have it here if you don't remember. If you're looking up, angle of elevation, looking down, the angle of depression, and your hypotenuse changes the side. Here is the last one. So if I read it for you, it says a 40-foot ladder, that's what I have here, it's 40 foot, leans against the building. If the base of the ladder from the base of the building is 6 feet from the base of the building. So from the ladder to building is 6 feet. Here it says, what is the angle formed by the ladder and the building? So we have three options of where this angle could be. It could be here, it could be here, or it could be up here. But they're saying, what is the angle formed by the ladder and the building? That can only be the spot right here. So we're not going to be looking for on the sides anymore. We're going to be looking for the angle. So now, from what they gave us, we have 40, we have 6, we have a missing angle. We don't need all the three sides to solve for these things. Here, from this angle, we always focus from that main angle. We're going to see what 40 is. 40 is considered the hypotenuse. It's that longest part there. So it's a building, so a building is always creating a 90-degree perpendicular angle. So it's 90. Across from that is always a hypotenuse, which is 40. And here, comparing it to the angle here, this is considered the opposite side. So now we have to find a function that uses the hypotenuse and opposite, and that's the first one, sine. So now we have the sine of theta. You don't know what theta is. Or we have x. I can't put this theta in the calculator, so I just put x. Sine of theta is equal to the opposite over hypotenuse. So let me go ahead and write that again. So sine of theta is equal to opposite side, which is 6, over hypotenuse, which is 40. And now we go ahead and solve for this. 6 divided by 40 gives you 0.15. So try to solve it out. I think you could put it as a fraction in your calculator if you use the inverse sign, but I don't know. Now, we have sine of theta equals 15. We're trying to find what this angle is, so we need to get that theta by itself. And to get it by itself, you multiply both sides by the inverse sign. This cancels out this, and you're left with the theta by itself. And now you have the inverse sign of 0.15. And in your calculator, if you have the TI, I don't know about the calculator, but here, sine is right there. So inverse sine, you do second, and you do that. And you have the inverse sine of 0.15 or 0.15, and you end up with a number like that. I'm rounding it to the 10th place, so I get about theta being 8.6 degrees. It's not very much. All right, if you have any more questions, make sure to let me know. Always look at this drop-down box over here if there's any new information that you need to know. Miss you guys. Bye.